So today we're going to learn about segments that are divided proportionally, and I would like to connect this to similar figures, in this particular case, similar triangles. So the first theorem on this is if a line is parallel to one side of a triangle, if a line parallel to one side of a triangle intersects the other two sides, it divides them proportionally, which means that in this particular case, given triangle ABC, so triangle ABC, and D is on AB and E is on AC, and segment DE is parallel to segment BC. We can conclude that AD over DB is equal to AE over EC. I would like to extend the lesson by saying that triangle ADE is going to end up being similar to triangle ABC. And the reason for that is because I will be able to prove this using the AA similarity postulate. So the first pair of angles that are corresponding and that are congruent are angle A is congruent to itself by reflexive property of equality. And so that's my first pair of A. My next pair of A can either come from angle ADE or angle ADE and angle B, or angle AED and angle C. Let's use this. So if these are parallel, then this serves as the transversal. So if that's the transversal, then angle AED and angle C are corresponding angles. And in this case, corresponding angles are going to be congruent because your DE and BC are said to be parallel. Because of that, then I can say that my triangles are going to be similar. This tiny triangle right here, ADE, and triangle ABC are going to be similar. Because they're similar, then the following things are going to happen. So all the angles, all the corresponding angles are going to be congruent. So angle A congruent to itself, angle ADE and angle B are going to be congruent. Angle AED and angle C are going to be congruent. And not only that, the corresponding sides are going to be proportional as well. So what are the corresponding sides in this case? Side AD over AB. So the whole thing, AB. So AD over AB are going to be proportional to AE over AC and DE over BC. That's going to happen when your triangles are similar. So the next theorem on segments divided proportionally has something to do with parallel lines that are cut by a transversal. On any two transversals, on any two or more transversals, parallel lines cut off segments whose lengths are proportional. So in this particular case, we have line 1 parallel to line 2, parallel to line 3. And we have these three transversals, AC, GI, and DF. What's going to happen here is if your lines are parallel and they're cut by a transversal, those parallel lines are actually making proportional segments out of your transversal, which means that AB, so AB over BC is going to be equal to GH over HI and is going to be equal to DE over EF. So the last theorem for our segments that are divided proportionally, the theorem states this. The bisector of an angle of a triangle divides the opposite sides into segments whose lengths are proportional to the lengths of the other two sides. So what does this mean? We are given triangle ABC and AD is the angle bisector for angle A. So what does this mean is that BD over DC is equal to BA over AC. But it's also the same as when I start this way, when I go to CD over DB, that is also equal to CA over AB. So those are going to be proportional.